Hi, kids. Okie dokie. We're going to talk a little bit about graphs and going from graphs from one type of graph to another type of graph. But a couple things I just want to make sure you understand. When you look at graphs, and this is going to be true, one of the beautiful things, there's many beautiful things about physics, but one of the beautiful things about physics is typically for certain types of problems, you always do the same thing. And guess what? All year long, be it in our momentum unit, be it in rotation, be it in kinematics, you're going to be talking about graphs. Okay? When you talk about graphs, there's always three things you're going to look at. You're going to look at the graph. So, for example, okay, if you had a displacement versus time graph and you looked at the graph, what would it tell you? Yeah, that would tell you displacement. Or a velocity versus time graph. If you look at the graph, it would tell you things like, hey, your velocity. Remember, your velocity tells you how fast you're going, so you would know how fast you're going. And it would also tell you the direction you're going, because that's velocity. So just be careful. If the graph, first thing you do is you look at the graph. You could look at the slope. Okay, you could look at the slope of the graph. Now, we're going to do this, but I want to make sure that you absolutely, totally, 100% do not try to memorize things, okay? So that if you try to memorize every single graph in this class, you are completely missing the point. Don't memorize, understand, okay? So rather than memorize, I'm going to memorize that the slope of a displacement versus time graph tells me velocity. No, I'm going to think about it. Think about, slope. Slope is rise over run. If my rise is x and my run is t, I have x over t. What is that? Oh, yeah, that's velocity. Okay, that's what I want you to do. Or, what is the slope? Well, it's the change in v over t. What is the change in v over t? Oh, yeah, that's a. Oh, yeah, the slope will tell you, like you can figure that stuff out that way. And then the third thing you're going to do is you're going to be looking at the area. Okay? But the same thing is going to be true. Do not memorize. You're going to think and, look at the units. You're going to think about what you're actually doing and figure out what that tells you. So we'll talk about that more, all of that stuff in just a minute. But let's go back to this idea. So let's say I have a ramp and I have a car, and look, I did minor in art. You can tell that's a car. My car is starting from rest. My car is going to go down the ramp. Point B is going to be at the bottom of the ramp. And then it's going to go up a ramp that has the same incline. So whatever this angle is going to be exactly the same. And then it's going to go up, and it's going to slow down. Okay? And if we want, let's have it actually slow down and then go back down and then back up. Okay, so if I was to kind of draw a picture of what's actually happening. So here's this picture. Let's actually kind of draw some things, though. On the way down, my velocity is going to point this way. Okay? On the way down, my acceleration is also going to point that way. And if you wanted to, you could draw a free body diagram and figure that out, but my acceleration is going to point that way. Well, if my velocity points this way and my acceleration points this way, I'm going to speed up going that way, okay? On the way up from here to here, my velocity is going to point this way, but my acceleration is going to point down the ramp. Okay, and again, draw your free body diagram if you're not sure. But look, if I'm moving this way and accelerating this way, what am I going to do? Well, I'm going to slow down, and eventually I'll stop, and then on the way back down, my velocity would move this way, and I would also accelerate that way because, hey, draw your FBD and it's going to be the same. Well, what am I doing? Well, now I'm moving the opposite way, but look, I'm accelerating the same way. I'd speed up. Oh, well, duh, that makes sense. And then over here, I would be moving this way, but still accelerating down the ramp, so then I would be slowing down again. Okay, so now we need to graph that. So we need to graph that motion. So from A to B, I am speeding up going forward. I'm going to call positive x the forward direction, negative x the backwards direction, just to simplify this. So speeding up going forward. So speeding up going forward. Okay, now remember, how do I know that I'm speeding up? Because for each time interval, I'm gaining more displacement, or if you like, and this is where we're kind of going here, is that the slope. What does the slope of this graph tell me? Well, this is meters, this is seconds. So if I do the slopes, I get rise, which is meters, over run, which is seconds, which is, hey, that tells me the velocity. But again, you're not going to memorize that. You're going to understand it. The reason that it tells me velocity is because it's x over t. Change in x over t is velocity. Okay? So the first part, hey, I'm speeding up going forward. My slope is positive and it's getting more steep. And then from B to C, so this would be like A to B. And then from B to C, I'm slowing down going forward. Slowing down going forward. And then at point C, I stop for an instant. So if I looked at my slope, it would be horizontal. Okay. And then from C back to B, I'm speeding up going backwards. And then I'm slowing down going backwards. Okay. And I end back up. And I end back where I started. So you'll notice my displacement from my start to my finish is 0 because I started here, I ended here. Okay, assuming there's no friction and the car ends up back at that spot. Okay, but so hopefully that makes sense. So moving forward, speeding up, moving forward, slowing down, moving backwards, speeding up, moving backwards, slowing down. So let's just make sure that this does fully make sense. If I was to draw little tangent lines here, so I'm drawing little tangent lines. Okay, because that's how do you see how my tangent line starts out horizontal because it's not moving, and then do you see how the tangent line is getting steeper for this first part, so I'm speeding up. It's getting less steep for this part, so I'm slowing down. It's getting steeper, so I'm speeding up. It's getting less steep, so it's slowing down. Or if you like, take your pencil and just kind of do this as I move along, and you can see how the slope changes. Okay? All right, so there's my x versus t graph. If I wanted to do my v versus t graph, couple things you can do. I'll show you a couple different ways you can think about it. One, let's think about it this way. I'm going to do my point A. Point A, how fast am I moving? Well, I'm not moving. Okay, so there's point A. Point B, which way am I moving? Well, I'm moving forward, so I have to be over here, because remember, positive velocity tells you you're moving forward in this case. And then it's more than 0, so I'm going to have a point B here someplace. Okay, then I'm going to have a point C here because I'm going to be stopped again. And then point B now, when I return to point B, now I'm going the opposite way, and then it goes back to here. Okay, so you can think of it that way if you want. The other way you can think of it is you can think of it like, think it through. Well, I'm starting from rest. I'm speeding up going forwards. Okay, if I'm speeding up, if you imagine numbers, hey, 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Hey, look, I sped up. Okay, that is speeding up. So, and then I'm slowing down going forward. If I was imagining numbers, 4, 3, 2, 1, 0. Okay, and yes, that should be a straight line. And then for this next part, where I am, this would be point C, when I'm going back down. For this next part, it would be, well, now I'm speeding up going backwards. That should have the same slope because it's the same acceleration, which we'll talk about. And then I would go back to here. So this would be like my point B, and then this would be my point A. Now, okay, so a couple things that I want to make sure make sense. So hey, look, 0, 1, 2, 3, I'm speeding up going forward, I'm slowing down going forward, speeding up going backwards, slowing down going backwards. So again, what does the slope of this graph tell me? Well, the slope of this graph is going to be the change in velocity over time. Well, what is that? Oh yeah, that's my acceleration. Or I could look at units. Rise, what are the units for the rise? Well, the units for the rise is meters per second. What's the units for the run? Seconds. Oh, meters per second per second. That's acceleration. So you don't have to memorize. The units, the graph, everything is going to be explained to you if you think about it correctly. Okay? You're not going to memorize, you're going to think. The other thing, if you were to look at the area of this graph, so let's say, hey, I wanted to do just the area of this first piece. Okay? Well, what is that shape? Oh, that's a triangle. You could find the area of a triangle. Yes, you could. But if you take a look here, guys, so it'd be 1/2 base times height. Well, what is the base in this case? Well, in this case, the base is time. So I really have time times, it would be really 1/2 times my velocity. Okay? Well, if you think about my units, I would have seconds times meters per second. Oh, wait a second. My seconds go away. Oh, what would the area tell me? The area would tell me my displacement. So the area of this graph is going to tell you displacement. So if I was to figure out a number of this area here, and let's say I got 2, well, that means this number here would be 2 because that's how far away I am. If I was to do this piece, the area of this piece would also be 2. So the area of this whole thing from A to C would be 4. That's because it moved 2 and then it moved 2 more. Okay? So like this would be 4. So the area tells you, in this case, the area of a V versus T graph tells you your displacement. Now look, down here, this area, if this is 2, this area would be -2. Like if this is +2 meters, this would be -2 meters. Well, what does that mean? That means I moved backwards. So, hey, look, I moved 2 forward, and then another 2 forward, and then I moved 2 backwards, and then I moved another 2 backwards, and look, 2 plus 2 plus -2 plus -2, hey, that's 0. So therefore, my total displacement would be 0. Hence, I end up at my starting point. Okay, so the area of a V versus T graph tells you your displacement, where the slope of an X versus T graph tells you this. And then if I wanted to go this way, my slope of this graph tells me this. And guess what? The area of this graph is going to tell me this, which we'll get to in a minute. But if I wanted to draw this graph, you could do it a couple different ways. Hey, look, I'm accelerating in the positive direction. If you think about your FBD, it's the same the whole time. So I would have positive acceleration here. This part, do you see how I'm accelerating in the negative direction? So that would be negative acceleration. Coming back this way, I'm also accelerating in the negative direction. That would be there. And then I have a positive acceleration. That would be there. Okay, so this is, again, where it's super important. If you look, positive acceleration here is speeding up. Negative acceleration for this first part, so like this is point A, B, C, this would be B, like this point would be B, and then A, if you look, speeding up, slowing down, speeding up, slowing down. So don't think, oh, positive acceleration always means speeding up. It doesn't. It depends on which way you're moving, okay? But the other way you can think of this is you could think of it, so you could think of it in terms of your FBDs, your force here, your net force is constant and it's pointing down. Here it's constant, it's pointing backwards. Or you could think of it like this. the slope of this graph? Well, the slope of this graph is positive, so therefore this has to be positive. The slope of this graph is constant, therefore this is constant. The slope of this piece is negative, negative. The slope of this piece is constant, therefore it has to be constant. Same thing, negative constant, and then positive constant. Now, you might ask, well, what is the slope of this graph? Well, the slope of these would be 0 because my acceleration isn't changing during these parts. But the slope of this graph would be meters per second squared per second, which actually has a name. It's called a jerk. But yeah, see, I don't want to be a jerk. We're not going to talk about a jerk. And for our purposes, it's not important. Okay? But the area, so like if I wanted to find the area, I would find the area of this piece. Okay, remember when you're finding area, it's always with the x-axis. So like, hey, look, I'm going to find this area. I'm going to find this area. Well, the area would be base times height. So if you think second times meters per second squared. Well, if I do this, I end up with meters per second. So what does that tell me? That tells me velocity. So another way you could do this, if I wanted to know my velocity at the bottom, well, what would I do? We already said it was 4. That would mean the area of this has to be equal to plus 4 meters per second. Now, remember, the 4 was just a number I made up, but if I just stay with that number. So plus 4 meters per second, that means this is negative 4 meters per second. Well, guess what? If I have plus 4 meters per second, and then I take away 4 meters per second, I'm stopped at point C. And then this would be negative 4 meters per second. Well, what does that mean? Because that means after I went back down, that's how fast I'm moving, 4 meters per second, and I'm moving in the opposite direction. And then this would be plus 4 meters per second, which means when I get back to here, I'm not moving again, which is what that shows. Okay? So the couple big super duper important takeaways, guys. 1, you're not memorizing. 2, you are always going to be doing one of these 3 things when you have a graph. You look at the graph, you look at the slope, you look at the area. You know, if there is a question that said, hey, if you had this graph, just the A versus T graph, and it said, what is the acceleration at, point C? Well, point C was right here. You would just go look at this graph and go, boop, 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 boop. Oh, it's negative whatever that number is, and just figure that out, okay? If you had this graph, a V versus T graph, and it said, what is your acceleration at point C? Well, then you would have to be smart enough and go, well, point C is here, but this is a V versus T graph. To find acceleration, I have to look at the slope. Well, how do I find the slope? Well, pick 2 points and, y2 minus y1 over x2 minus x1. You'll notice that a lot of people go, oh, the slope is 0. No, it's not. The slope there is negative. The value is 0, but the slope isn't 0. Hopefully everybody sees what I'm talking about. But, so if I had this graph, then how would I find the acceleration? Well, I would look at the slope. If I had this graph, how would I find the acceleration? Well, you'd have to draw this graph and then find the acceleration. Okay, so again, it all depends. I can't just say, well, always do this. No, you gotta think. If you had this graph and you are asked to find velocity, well, what would you look at? You look at the slope. Well, if you have a curve, if it's a line, just find the slope. But if it's a curve, then you would have to draw a tangent line and find the slope of that tangent line. For example, at C, that would be your tangent line. Hey, look, the slope of that is 0. Hey, look, I'm not moving at point C. Okay, so make sure that you're always thinking about this type of thing. All right,